Hello, my name is Joyce, and I will be presenting a screencast on the hypothesis test for correlation p-value from a t-test. Okay, so there will be pieces of information that you'll need to know before you can solve a problem for this. So first off, these are the two hypotheses that we are looking at. We have our null hypothesis and our alternative hypothesis. And depending on whether we reject or fail to reject our null hypothesis, that will be our answer in determining whether there is a linear correlation or not. And whether or not we reject our null hypothesis or not will depend on our calculations. So in our calculations, we will need the t-test statistic formula, which is shown right here. We will also need to know the p-value, which can be found through this command in Excel. And so x will be our t-test value and df will be our degrees of freedom value, shown right here. And this will tell us whether or not we reject or not reject our null hypothesis. And we'll compare our p-value to the significant level that is given in our problem. So I have included a summary of all the information that we need to know for us to solve our problem. Okay, let's open up Excel to solve a problem. An example: cost of pizza and subway fare. Okay, and I also included the summary here in this corner so you can look at it and reference to it while you are solving it. So before we start solving this problem, make sure that you have the data analysis pack in your Excel. So it would be included over here. You go to data and data analysis, and you'll have this nice little menu for you to choose from. So make sure you have that. If you don't, make sure you install it before you start this problem. Okay, first thing we want to do is to find the correlation between the cost of pizza and subway fare. So what we want to do is open up our data analysis, click on correlation, OK, and select our input range. And I already have something selected here, so I'll just erase that and do it again. So our input range is these two columns. You want to select both of them. And then let's pick output range and just click on that box and select where you want your output to be shown at. And then OK. Alright. We have our correlation value. This is our correlation, and I'm just going to highlight that. Okay, next we want to have is our t-test statistic, and we will find that using this formula over here. So t-test. I like to just plug in the values into this formula to find it. And so you can just do that on a calculator. I will show what is like plugged into the formula right here. So this is what you should get. So yeah, you just plug in R 0.988 and n is how many points you have here, which we have 6. And then, yeah, you just plug everything in, and you should get 12.793. 12.793. And when you plug this into your calculator, make sure you use all of the decimal points. Don't round off like that because it might throw off your answer. Okay, we have our t-test statistic. Now we want to find our p-value. And we do that using this command in Excel. So just type that in, equals t.dist.2t. Open parentheses, x is our t-test value, so I'm just going to select that, comma, degrees of freedom, which is, as we remember, is n minus 2. Like right here. So n is 6 minus 2, and we get 0.0002. Okay. Alright. Now we have all the information that we want. So, actually, we don't. We have our p-value, but we need our significant level. And I actually forgot to give you guys the significant level. So let's just put that out here now. The significant level is 0.05. So let's compare our p-value to our significant level. It looks like that our p-value is smaller than our significant level. So that means our null hypothesis is rejected because our p-value is smaller than our significant level. Therefore, the null hypothesis is rejected. And we want to, so we have these two, and we want to circle back to our initial hypothesis of what our null hypothesis says. So our null hypothesis says that there is no linear correlation. We reject this null hypothesis, so we accept, per se, the alternative hypothesis. So that means there is a linear correlation between the cost of pizza and subway fare. So there is a linear correlation between the cost of pizza and subway fare. Can't really see that, so I will scoot this down a little bit. Okay. So that is our answer on analyzing our hypothesis and information. So after watching the screencast, I hope you know how to solve a hypothesis test for correlation p-value from a t-test. Thanks for watching.